All right, remember yesterday we did multiplying, dividing, and simplifying. Today is adding and subtracting. It's just like, remember, a rational expression is just like having a fraction. The only thing that's different here is that it's going to be an expression instead of just number in your numerator and a number in your denominator. Your numerator or your denominator can have an expression, variable, however you want to look at it. So, whenever we add and subtract with like denominators, it's the same thing. Remember, just like any other fraction, if it has the same denominator, then you're just going to add straight across. You do not add the bottom. Okay? The only thing you do is add straight across. I'm still going to have students that are going to get in too big of a hurry, and they're going to try to, in this case, they're going to try to subtract x squared minus 9, and then take x squared minus 9 and subtract those two values. Well, what's going to happen on the bottom if they have like terms? They're going to cancel. They're all going to go away. Okay? That shouldn't happen. Okay? You should never end up with 0 on the bottom side because you can't divide by 0. Okay? So that's kind of your little hint or your little tip that I can't subtract or add the bottom, okay, in some cases. Now like 12, it's not going to cancel, but it would double. So if we look, first things first, I still need to check to see what are my restrictions down here. Like, what can x not be? Can it be positive 3 and negative 3, right? So x can't be plus or minus 3. I still need to check that in the beginning. Okay, that hasn't changed. Okay, because if it's 3 or negative 3, then you don't have a problem to work with. Okay, so I want to know what that restriction is before I start, and then again, just like yesterday, I can always add to it. I can never take a restriction away. Okay, so then it just becomes a standard problem, and usually whenever I do this or what I go with, I usually put everything under one big equation, or one big fraction, so x squared minus 9. Now, if you want, you can change that to x plus 3 and x minus 3. That's okay with me. Have no issue in that. Now, for me, I'm going to rewrite it and go 5x plus 1. Now, if it's a minus, that means I'm just going to change all the signs and have minus 4x plus 2. The top side is just going to get combined as far as the terms. So 5x minus 4x is just x. 1 plus 2 is plus 3. Now, the reason why you probably want to factor this part right here with x plus 3 and x minus 3 is because what's going to happen with the top and the bottom? Is there anything that's going to cancel? Yeah, the x plus 3 and the x plus 3. So, what am I left with? What is it? Is it 0 over x minus 3? What? So we know it's x minus 3 down here. What are we going with up on the top? We're going with 0? 1. Why 1 and not 0? But it went away. That's what I'm going to hear. But it went away. It's gone. Remember, it's dividing. So it's 1. And then x still cannot be equal to plus or minus 3. Same way on 12. The only thing different here is that we're going to add. So before I start, what are my restrictions? What can x not be? negative 1, right? Now, if you want to write it all together, I'm just going to go x plus 1. If you feel like you can take x plus 3x and have 4x, and then there's no constant and just go plus 5, that's completely okay. If you don't want to write like I did up here, and you just want to add it straight across, that's fine. The biggest thing, usually addition's not the problem. It's whenever we do subtraction, because we forget about that sign on the back end here. Just make sure that you don't forget to change that sign if it's subtraction. X still can't be negative 1. Nothing can cancel, so I'm just going to leave it as is. Now, it said on the title slide, it said this is the Welcome to the Hotel California. Okay? If you know about the Hotel California, it can be heaven or it can be hell. Okay? Heaven is fractions and rational expressions with common denominators. Adding and subtracting with unlike denominators seems to be not so much of heaven for some students. Okay? Fractions are the devil's work. Just ask most high school students, especially the ones that are shaking their heads, because the smoke starts coming out of their ears and the hamster does not want to run on the wheel. So whenever we add or subtract with different denominators, we have to get a common denominator. And to be perfectly honest with you, it's a lot easier with rational expressions, in my opinion, than it is fractions. Okay? Because with a rational expression, you want to factor everything out, okay, or at least factor the bottom. You don't have to factor the top. Factor the denominator, and then look for the highest power of each factor. Okay? If you're missing something, then that fraction or that rational expression will need that part. Okay? You have to make sure that everything matches. Okay? So the only thing I ever have to really factor is the bottom side, is the denominator of each fraction or of each rational expression. Okay? So, like in this case, if I have 7 over 5x squared plus 15x, and I have 9 over x squared plus 6x plus 9. So what, again, the bottom or the top side, I'm not really worried about. I'm really worried about the bottom side and what's down there. So of 5x squared plus 15x, what can I factor out of 5x squared plus 15x? 5x. What am I left with? X plus 3, right? Of x squared plus 6x plus 9, it factors out to x plus 3 and x plus 3. Now, I like to write 2 of them just so I can tell myself how many of these do I need. So what I want to do is I want to look at each individual part. On the one on the left, I have 5x times x plus 3. On the one on the right, I have x plus 3 and x plus 3. What does the one on the left need that the one on the right has? Another what? Another x plus 3. So whatever I do to the top, I'm going to do the same thing to the bottom. Okay? I like to write it in different colors so then we kind of know what I have. Now, what do I have? Does everything that I have in the second rational expression or the second fraction, do I have it in the first fraction right now? From the second one to the first one, not the first one to the second one. Yeah. But now, do I have everything in the second one that I have in the first one? No. So what do I need in the second one? A 5x, right? So I would just go 5x and then 5x. All I'm trying to do is get the bottom side to where they match or where they look the same. Whenever we add or subtract rational expressions, you're going to do the same thing. Basically, what we did on that last example is the same technique. You're going to see we're going to factor the bottom, and then we're going to multiply the numerator and the denominator by whatever is missing. Okay, so whatever's missing in each fraction, or whether it be one fraction or two fractions, depending on, or maybe three, who knows, whatever we have, and we just make sure that everything matches on the bottom side. And then whatever's on the top goes on the bottom as far as the missing part. You'll multiply the numerators if you have to distribute or you have to multiply binomials, whatever. Do that. Then you'll either add or subtract, and then simplify further. So basically, leave the bottom factored, and then if you can factor the top, factor the top. We still need to worry about what our restrictions are. Okay, that hasn't changed. So if we look at $14, what's going to factor here? X squared plus x minus 2. How does that factor? X plus 2, x minus 1. How does that one factor? X plus 1, x minus 1. So now worry about what does the other one need. So if I have, if I have x plus 3, and I'm going to go ahead and put it in parentheses, what do I need to multiply this first one by to where it has everything that's down here? What am I missing? Another x minus 1, right? So I'm going to go x minus 1, x minus 1. Oh, plus 1, my fault. There we go. X plus 1 and an x plus 1. What is the so now do I have everything that I'm missing from the second one into the first one? Yeah? What am I missing from, so I have a 2 up here. What am I missing in the second one? X plus 2. So then at this point, I'm going to go ahead and write out just kind of below what my restrictions are. Like, what can x not be? X can't be a plus or a minus 1. And it can't be a negative 2. Okay? I'm just going to kind of keep this here and use it for later. So now, this is where I will basically write one long fraction and kind of do a couple things at once and have x plus 1, x minus 1, and x plus 2. I'm going to go ahead multiply those two out. So x squared plus 4x plus 3. Then I'll go ahead and multiply my other one. Pay attention to the sign that I have here to make sure that I don't have to change anything. If it's a plus, it's nice and easy. I don't have to change anything. So I'm just going to have 2x plus 2, 4, excuse me. And then just add across. So bottom doesn't change. X plus 1, x minus 1, and x plus 2. Then combine the top side. So x squared plus 6x plus 7. From here, check to see if I can factor out the top. So two numbers that multiplied together to give me 7, add to give me 1. Or add to give me 6, excuse me. So no. Okay? So if it doesn't factor, then that means I can't cancel anything. I'm just going to tack on at the end that x cannot be equal to plus or minus 1 and negative 2. Now, whenever we have complex rational expressions or a complex fraction, basically you have a numerator and a denominator on top, and then you have the same thing on bottom. It looks like one really big fraction, okay, that's just dividing. It's complex because you're going to have to add and subtract, and then you're going to basically have to divide. That you can either turn into a multiplication problem or not. It's completely up to you. I'll show you two different ways, or I'll show you a way that I use. The fraction bar is just a division symbol. That's no different. And then excluded values come from anywhere that the denominator could be 0. Okay, in the original and then in our finished product. So if I'm going to go ahead and do 17 because it's a lot more complex. With a complex fraction, focus on one thing at a time. So for right now, I'm basically going to just forget about, I'm going to forget about everything down here. I'm not going to worry about it. I'll come back to it in a minute. So whenever I do that, I need this fraction and that fraction to look the same. So whenever I rewrite it, basically what's going to happen is I'm going to have a fraction bar here, and then I'm going to have another fraction on top of it. Okay? It's going to look something similar to this here. So, what's my denominator? I have x minus 2 as my denominator in the first part. What's my denominator right here? Of 1. 1, right? What's another way to write 1 with a denominator of x minus 2? X minus 2 over x minus 2. So realistically, I'm looking at x over x minus 2 plus x minus 2 over x minus 2. So what's my denominator going to be right here? Because this is like my new problem. What's my denominator? X minus 2, right? So now x plus x is 2x minus 2 Now, for me, what I'm going to do is I'm going to go ahead and factor that out because, and I'll show you that, and I'll show you why in a minute. So, for me, if I factor it, it's just going to make it a little bit easier later. I'm going to have 2 times x minus 1 and then I'm going to have x minus 2. Once I get the top taken care of to where it is a fraction on the top side, now we can go and we can start looking here. Okay, if you need to, just kind of block off the top. We're done with it. And let's just focus right here. So again, we have 1. So I have x squared. What is x squared minus 4? X plus 2 and x minus 2. And I have a 3 on top. Plus, now I factored it. I'm going to go x plus 2, x minus 2. Now, do I want to have it factored right here? Do I want to factor it out on top and have x plus 2, x minus 2? Wouldn't it be smarter just to leave it unfactored here? Because what am I going to do with the 3 and the negative 4? I'm going to combine them, right? So whenever I do that, I have x squared minus 1, and then I have x minus 2, x plus 2. Can I factor? This part's already factored, x plus 2, x minus 2. Can I factor right here? X plus 1, x minus 1. Now, if you had me in class last year, I did it a certain way. If I left them stacked. Okay. First things first. What are my restrictions? What can x not be because of the denominator here and there? What can x not be? Plus or minus 2, right? Now, here's where I differ from other people, and I'll write you out kind of my steps. First thing, if you have a complex fraction, question? I'm not stupid. I may look funny, but I'm not stupid. All right, so my steps are what, and I'll kind of write these over to the left. My steps that I use whenever I simplify complex fractions, you can still do keep, change, flip, and do it that way, and if that's what you want to do, that's fine. How I do it is the first thing I'm going to look to do is I'm going to cancel matching parts of the numerator. So what that means is that yellow fraction bar is it's my dividing line, right? So is there anything up on the top side here that matches on the numerator side? So like the x minus 1. I have an x minus 1 here, and I have an x minus 1 here. I go ahead and cancel it that way. Okay, and I'll show you the keep, change, flip in just a second, because it's still going to work out to be the same way, and it's completely up to you as far as how you do it. So if the first thing I did was cancel matching numerators, matching parts of the numerators, what do you think step 2 is going to be? Cancel matching parts of the denominator. So, matching parts of the denominators, I have an x minus 2 and I have an x minus 2. Step 3, multiply, whoop, outside parts. Your outside parts are your new numerator. And whenever I say outside parts, basically everything that's left, so the 2 and the x plus 2. Okay, so if it's my new numerator, I'm going to have 2 times x plus 2 on the top side. If we multiplied the outside parts, what do you think the last step's going to be? Multiply the inside parts, right? Now, whenever I say multiply the inside parts, so then I have the new denominator. So what's left on the inside? Just the x minus or x plus 1. Is there anything else that x cannot be as far as my restrictions? -1. So I'm just going to add that to my list. And whoop, go from there. Now, if you want to do keep, change, flip, I have no issue in that whatsoever. All you're going to do with keep, change, flip is you're going to take the top side, okay, and I'm going to write this in yellow here, is where I have the 2 times x minus 1 on top. So the top fraction's not going to change. I'll just make it into a multiplication problem. I'm going to flip this fraction. So x plus 2, x minus 2, and then x plus 1, x minus 1. Everything is still going to cancel just like it did before. And I'm still going to be left with the same things on top. That didn't change. My answer is still going to be 2 times x plus 2 all over x plus 1. It doesn't matter to me if you do it this way or the other way. Okay, I'm just trying to give you options. Alright. Your assignments here, 33 to 57 odd, then 59, 50, 65, 67, and 71. Those are your complex numbers. Okay, so the part here on the back side, these are where your complex numbers are going to live, and then these are just adding and subtracting. Just some have like denominators, some don't. So